Now see here, I am I have we that is after the steps, what I need to do is I need to find the transfer function, so that I need to combine y of z and x of z. So y of z I am combining here, and x of z here we are having. So y of z by x of z is equal to b by 2 1 plus z inverse. Remaining coefficient here you will have. So now you this is nothing but your transfer function h of z. So okay, so I have I am having in this form which I have taken previously, b by s plus a. So now I am comparing this with b by s plus a. So here when you compare this, what you are having for s is equal to 1 minus z inverse by 1 plus z inverse 2 by 2 I am having. This is in terms of z inverse, and also you can write it in terms of z. So this can be written as 1 by z. So taking LCM, z minus 1, here also you write 1 by z. So z plus 1, z will get cancelled. So z minus 1 by z plus 1. Here we have to write z is equal to r e power j omega. So what we are going to do, first I will tell, after this I will explain this what it is. So what we are going to do is, in this problem we have this h of s. So we are going to convert into h of z. How we are going to convert is by substituting s is equal to these value, either these one of these value. If you want to have h of z in term of z inverse, you are going to use this. If you want to have h of z in terms of z, I am going to substitute it. Wherever I am having z, that I am going to substitute this by 2 by t 1 minus z inverse by 1 plus z inverse. So automatically it will convert into the transfer function. Here there is no formula, only one concept. What it is, here we are going to substitute the value for s in terms of z in order to convert the analog transfer function into a digital transfer function. Now we will see the relation between the omega and ohm. Okay, there we have seen the relation between omega and ohm, right? That is omega is equal to ohm t. So here what we are going to do is, don't confuse with it, here we are going to derive the relation. So here z is equal to r e power j omega. I am going to write that is real term and in terms of angle, polar form. So s is equal to 2 by t, z minus 1, z plus 1, 2 by t, substituting r e power j omega minus 1, r e power j omega plus 1. So this can be written as cos omega plus j sin omega minus 1, or cos omega plus j sin omega minus 1. Separating the real term and imaginary term, I have written like this. Now I am going to find out the real part, and that is imaginary part. So I am multiplying by the complex conjugate. This is the real part and this is the imaginary part. So the complex conjugate is my minus. So multiplying on both numerator and denominator. So after multiplying and simplifying, what I am getting is, I am getting the term like this. So we know that s is equal to sigma plus j ohm. Now equating with this, that is the real part to this sigma and imaginary part to this ohm. So sigma, the real term, all the real term, so this part, okay, will come. And for imaginary term, 2 by t 2r sin omega into divided by 1 plus r square plus 2r cos omega. So ohm is equal to 2 by t. So you will get this term. Now here we are going to see some different condition. If r less than 1, then sigma is less than 1. If r greater than 1, then sigma greater than 1. So the left half of the S-plane maps onto the point inside the unit circle in order to have the stability. Now considered, we are going to assume this r is equal to 1, and we are going to take ohm is equal to 2 by t 2 sin omega 1 plus here I am having r. So 1 plus 1, here you will have 2, right? 1 plus 1 into 2 you will have, right? Here 2 you will have, here you are having 2, this 2 will get cancelled. So 1 plus cos omega. So 1 plus cos omega. So I am writing this formula, sin 2 theta. how we can write 2 sin theta cos theta. Here instead of 2 theta I am having omega, so here 2 sin omega by 2 cos omega by 2. Similarly here cos square theta can be written as 1 plus cos 2 omega by 2. So here I am taking this as 2 cos square omega by 2. So 1 cos omega will cancel, 2 will get cancelled. So what you will get is, you will get, one second, you will get as ohm is equal to 2 by t tan omega by 2. So we know the analog frequency, we need to find out the digital frequency alone. So digital frequency omega is equal to 2 tan inverse of ohm t by t. There we got omega is equal to ohm t. Now we got omega is equal to 2 tan inverse of ohm t by t. That is the entire range ohm is mapped only in the range, because here the maximum and minimum range is minus pi to pi. So here the entire range is mapped into the range minus pi to pi. So this mapping is non-linear. What will happen is, while transforming into minus pi to pi, the lower frequency in analog domain are expanded in digital domain, whereas the higher frequencies are compressed. Why? The reason is because of this tangent arc function, and this concept is called as frequency warping. This is one of the important question. What is frequency warping? So why we are getting here the lower frequency in analog domain are expanded in digital domain, whereas higher frequencies are compressed. This is due to this presence of this non-linearity of the arc tangent function, and it is usually called as frequency warping. So that's what about this bilinear transformation. Now we will see how to solve problem using this. Now consider this problem. H of s analog transfer function is given. I am going to apply the bilinear transformation to t h of s is equal to 2 by s plus 1 s plus 3, with assuming t is equal to 0.1 second. So first step is, we are going to obtain h of z. How we are going to obtain h of z is by substituting at h of s is equal to 2 by t 1 minus z inverse divided by 1 plus z inverse. So here t is equal to what? Here we are going to have h of s at s is equal to 2 by 0.1 1 minus z inverse by 1 plus z inverse. So it will become 20. So now what we are going to substitute is h of z is equal to, what is h of s? This one. So 2 by, wherever you are having h of s, that is, this will become 20. So 20 into 1 minus z inverse divided by 1 plus z inverse. For this I am substituting, okay, plus 1. Okay, this plus, same for this, yes, 20 into 1 minus z inverse plus 1 plus z inverse plus 3. Okay, now I need to simplify this, and I have to have one single term in the denominator, and remaining terms I need to transfer into the numerator. So I am going to obtain the transfer function. So after simplifying, it's a very normal simplification. So here I am getting the term like this. So what here we need to do is, finally you need to have this denominator in terms of this expression, so multiply it. So first term should be 1. So take this first term, whatever you are getting in the first term, take it outside and divide remaining coefficient by the same term. Okay, so that you can get the term like this. So in this is what the procedure. There is no other method, no other procedure involved in it. Just whatever the transfer function you are having, you are going to substitute. S is equal to 2 by t 1 minus z inverse by 1 plus z inverse, and by substituting the value t. Okay, and I will solve some more problems, and similar to this, and I will upload in the Google Classroom. Hope you have understand this bilinear transformation. Now we have completed this conversion of analog transfer function into a digital transfer function. Thank you.